So section 5.3 is multiplying decimals and the circumference of a circle. When it comes to multiplying, we're just going to kind of look like the numbers. So like, see how this is 7/10 times 2/10? The numbers are just 7 and 2, correct? So what we're going to do is we're just going to do the math with 7 times 2. And then at the end, we'll worry about moving the decimal to where it needs to go. So what is 7 times 2? 14, okay? Once you do the math multiplication, you go back and look at your original problem. How many spots were behind the decimal? 1, 2. So what we're going to do is, technically right now there's a decimal behind 14, but we're going to move it 1, 2 spots. So our final answer, guys, is 0.14 or 1400ths. Okay, so you just do the math like normal. So this one, for example, on B, think of it as 133 times -5. Do we really need to put the negative there? No, we just need to remember our answer is going to be negative, right? A positive times a negative. So we're just going to do 133 times 5. If you're a lattice person, you can still do lattice with all this as well, okay? So 5 times 3 is 15. Put down your 5, carry your 1. 5 times 3 is 15 plus 1 is 16. Put down your 6, carry your 1. 5 times 1 is 5 plus 1 is 6. Do you guys get 665 there? Okay. And so the decimal is always at the very end. So what we'll do is we'll go back and say we had 1, 2, 3 spots behind the decimal. So we're going to move it 1, 2, 3 spots. So our final answer is negative 0.665. Why is it negative? Because it's a positive times a negative. Okay? And that's something on my math lab, I just put a negative and not worry about it. Yes, ma'am?
So are you just counting the numbers behind
the decimals? Just the numbers behind the decimals, like total, right? So like this had 2 numbers behind the decimals, this had 1 number, so we had 3 numbers behind the decimal. That's all we're doing, okay? So C is 72 times 58. 8 times 2 is 16. Put down your 6, carry your 1. 8 times 7 is 56, plus 1 is 57. Is that okay? So 576 for that first round. Then when we shift to the 5, remember we got to shift over, so I put a 0 there. And you do 5 times 2 is 10, carry your 1. 5 times 7 is 35, plus 1 is 36. Does that look okay so far? So 3,600. And then we're going to add them up. 6 plus 0 is 6, 7 plus 0 is 7, 5 plus 6 is 11. So is that what you got originally, 4176, right? And then we're going to go count the numbers behind the decimals. We have 2, and so we're going to go 1, 2. So our final answer is 4176. And kind of stop and think about your problem, the original problem that we're dealing with. We are multiplying something a little more than 7 and a little less than 6. What's 7 times 6? 42. See how our answer is kind of close to 42. So that's kind of a way to keep in mind that we've been doing it. Here, this was a little over 1, and that's only a half. What's half of 1? A half, 0.5, right? So see how this is kind of that smaller number. So when we multiply these, this is not quite 1, and that's really small, so our answer is really small. When we multiply these, think about whether the answers make sense, okay? So D is just, they're setting it up for you. You can keep the decimals there, that's fine, but just kind of ignore them, okay? Think of it as 856 times 31. And again, if you want to do the lattice, you can do the lattice method and then just move your decimal at the end. So 1 times 6 is 6. 1 times 5 is 5. 1 times 8 is 8. So I got 856 on that one. When I shift over to the 3, I got to shift over, so I'm putting a 0. 3 times 6 is 18. Put down your 8, carry your 1. 5 times 3 is 15, plus 1 is 16. Put down your 6, carry your 1. 3 times 8 is 24, plus 1 is 25. Okay, so no decimals anywhere, and we're just going to add them up. 6 plus 0 is 6. 5 plus 8 is 13. 1 plus 8 is 9. 9 plus 6 is 15. Put down your 5, carry your 1. 1 plus 5 is 6. So then 2. Is that the number you get, guys? 26536. Does that look right? And then you go back to your original problem and you say, well, how many values did I have behind my decimal? I had 1, 2, 3, 4 numbers behind my decimal. So I'm going to move my decimal point 1, 2, 3, 4 spots. So 2.6536 is your answer. And again, to check the math, we took 3 times something that was less than 1. So we're going to get a number less than 3. E and F, again, I got these in PDF form, so I couldn't really change them. But E just act like the 6.9 is kind of shifted over. So we're going to do 9 times all that jazz and then 6 times all that jazz, okay? So 9 times 3 is 27. Put your 7, carry your 2. 9 times 3 is 27 plus your 2. So that's 29. Put down your 9, carry your 2. 9 times 0, 0 plus 2. And then we're going to have a couple zeros, aren't we? 9 times 0 is 0. 9 times 0 is 0. 9 times 2 is 18. Does that look right, guys? And 18, 2 zeros, and then 297. Okay. We're going to shift when we go to the 6. So I'm going to put a 0 down. And then I'm going to multiply 6 by all this stuff. So 6 times 3 is 18. Put down your 8, carry your 1. 6 times 3 is 18 plus 1 is 19. Put down your 9, carry your 1. 6 times 0 is 0 plus 1. 6 times 0 is 0. 6 times 0 is 0. 6 times 2 is 12. That's a really yucky number there. Okay, let's see if we can line them all up okay. So 7 plus 0 is 7. 9 plus 8 is 17. Put down your 7, carry your 1. 1 plus 2 is 3. 3 plus 9 is 12. Put down your 2, carry your 1. 1 plus 1 is 2. 0 plus 0 is 0. 8 plus 0 is 8. 1 plus 2 is 3. And then 1. Does that look right? And then let's see how many numbers do we have behind their decimal. 1, 2, 3, 4, 5, 6. Does that look good? Yep. So 1, 2, 3, 4, 5, 6. So it gets us to the 13. So we have 13.802277. And then the signs, guys. What's your sign when you multiply a negative times a negative? Positive. So we don't have to worry about that. And again, I know it's crazy, but we did it. And think about what we did. We did something like 2-ish times 7-ish. What's 2 times 7? 14. Isn't this kind of close to 14? So kind of do that little estimate in your head to make sure that it looks right. F, guys, I think this is just way too far off, so I'm just going to write it over here. 896 times 345. And I'll go back here to see where my decimals are, but when I'm doing the actual multiplication, I'm not going to worry about my decimals, okay? So 5 times 6 is 30. Put down your 0, carry your 3. 5 times 9 is 45, plus 3 is 48. Put down your 8, carry your 4. And then 5 times 8 is 40, plus 4 is 44. Does that look right? 4480. I'm going to shift over to the 4 now, but since I'm shifting over to the 4, I have to shift over down here. So I put a 0. 4 times 6 is 24. Put your 4, carry your 2. 4 times 9 is 36, plus 2 is 38. Put down your 8, carry your 3. And then 4 times 8 is 32, plus 3 is 35. Does that look okay? So 35,840. Now I'm going to the 3, so I shift over twice. So I have to shift over twice down here with 2 zeros, and it's going to be 3 times everything. 3 times 6 is 18. Put down your 8, carry your 1. 3 times 9 is 27, plus 1 is 28. Put down your 8, carry your 2. And then 3 times 8 is 24, plus 2 is 26. Woo, okay. The first column is all zeros, so that's just going to be 0. Then we have 8 plus 4 plus 0 is 12. Put down your 2, carry your 1. 1 plus 4 is 5. 5 plus 8 is 13. 13 plus 8 is 21, I believe. So we'll put a 1, carry your 2. Use your fingers, do whatever you need to. 2 plus 4 is 6. 6 plus 5 is 11. 11 plus 8 is 19. Put down your 9, carry your 1. 1 plus 3 is 4. 4 plus 6 is 10. Put your 0, carry your 1. And then what do we have? 1 plus 2 is 3. Woo! Okay, so we get this, looks like a large number, but we have to go back to our original problem and count those decimals. So we have 1, 2, 3, 4, 5, 6, 7 behind the decimals. So we're going to go 1, 2, 3, 4, 5, 6, 7. What happens when we move all the way in front? We need a place value there. So what are we going to put there, guys? 0. A 0. So there's our final answer. And you're going to find when you take two numbers that aren't even 1 and multiply them, your number just gets smaller and smaller. Okay? If you take two decimals less than 1 and multiply them, your answer is really small. All right, so 2 is just the same idea. They're just kind of showing you a different way that they can start with multiplication. So in A, I'm going to multiply 68 by 32. That's all I'm going to do. So 68 by 32. I'll worry about my decimals at the end. 2 times 8 is 16. So put your 6, carry your 1. 2 times 6 is 12 plus 1 is 13. So I get 136 on that first part. Then I'm going to shift over 1, so I'll put a 0 and run through with my 3. 3 times 8 is 24. Put your 4, carry your 2. 3 times 6 is 18 plus 2 is 20. All right? So I end up with 2176. Does that look right? So then you just go back and say how many things were behind the decimal. 1, 2. So I'm going to move my decimal 2 spots to the left. So 2176. And notice the directions say multiply, check by estimating. This is kind of close to 7, and this is kind of close to 3. What's 7 times 3? 21. Look at our answer. It's close to 21, and that's all they mean by that, okay? So 8.4 times 1.8, I'm really going to do 84 times 18. So 8 times 4 is 32. Put your 2, carry your 3. 8 times 8, what is that, 64 plus 3 is 67. So I get 672 on that first go. I'm going to go run through with 1 now, but I got to shift over 1. 1 times 4 is 4. 1 times 8 is 8. And we're just going to add them up, okay? 2 plus 0 is 2. 7 plus 4 is 11. Carry your 1. 1 plus 6 is 7. 7 plus 8 is 15. So 15, 12. And again, I have 2 spots behind my decimal. Boop, boop. So I get 15 and 1200ths as my answer. Does that make sense? This is around 8. That's around 2. What's 8 times 2? 16. We're kind of close to that, so not too bad. All right, last one. 5.8, so really 58 times 0.7, so 58 times 7. Don't worry about those decimals at all. 7 times 8 is 56. Carry your 5. 7 times 5 is 35, plus 5 is 40. So I got 406. But I have to move it over 1, 2 spots. Woo! Okay, so I got 4.06. Does that make sense? Yeah, we took a number that was 6 and multiplied by a number less than 1. So if you multiply by less than 1, you're making it smaller, and that's why that answer is smaller. Are there any questions on the front? It's really just, it's kind of nice. It's kind of like that addition where it's nothing really new other than just shifting your decimal over at the end. So the next spot, what they have here, guys, A through F for number 3 is there's tricks to multiplying by powers of 10, okay? Can you sit here and do everything we were doing? Yes, you can do 43 times 10 and move your decimal at the end. But another way says when you multiply by a power of 10, you're moving your decimal point over by however many zeros there are, okay? So how many zeros does 10 have? 1. So guess what we can do? We can just move our decimal 1 spot. So 43 is our answer. Do you guys agree that multiplying by 10 would make your answer bigger? So we're going to move the decimal to the right to make it a bigger answer, all right? So what do you think we do when we multiply by 100? Move your decimal how many spots? Twice. So you just go 1, 2, so you have 1769.3. Is that okay? And then last but not least, what do you think we're going to do when we multiply by 1,000? Move it over how many spots? 3. 1, 2, 3. So we get negative 2.7. Is that okay there? So when you multiply by so we're counting how many zeros. So since there's 3 zeros there, I moved it 3 spots. 1, 2, 3. So put it right behind the 2. Whenever you multiply by big powers of 10, 10, 100, 1,000, you move your decimal to the right. However many zeros, right? Whenever we multiply powers of 10 that are small, we're going to move our decimal to the left. As many decimal points as there are, okay? Because we're just multiplying by 1, right? But when it's 0.1, we would move our decimal over 1 spot. So we are going to make him smaller because we're taking 0.07 and multiplying by a small number. So we're just going to move it over to the left. Why? Because there's only 1 decimal point. So we're going to move it over to the left 1 decimal point. So we get negative 0.007. Oh, is it negative? What should that be? Positive, right? It's a negative times a negative. I didn't see the negative on that guy. Wait, who said I'm confused? What? Okay. So did you write down our little trick that what we're going to do is we're going to multiply by a power of 10, okay? But when we multiply by 1, do you agree that anytime you multiply by 1, it's just going to be that number, right? Like what's 7 times 1? 7. What's going to be 9.07 times 1? 907, right? But we're not multiplying by 1, we have an extra decimal place. So what did we just do on the front page? Remember the front page? Is you had to count how many decimal places you had. So that's all we're doing. We're going to just move it over one spot. If you don't like this trick though, guys, guess what we can still do? 7 times 1 and get 7 and move it over 1, 2, 3 spots and you'll get that answer, Tanya. Okay, so if you don't like the shortcut, we can do the exact same thing we did on the front page, okay? So this one, how many decimal points do we have back here? 2. So what are we going to do to this one? We're going to move it to the left 2 because we're making it smaller. So what's our answer going to be? 0.0907. You guys see that? If you don't like it, take 907 times 1. What are you going to get? 907, and then you move it 1, 2, 3, 4 spots. 1, 2, 3, 4 spots. Guess what you get? The exact same answer, okay? So the book's just trying to show you powers are 10. You don't really have to do the full out multiplication, but you can. It doesn't hurt you. And honestly, with the decimals, it's not bad at all because you're just multiplying by 1 and then moving it over that many decimals, all right? So how many spots do we have back here? 3. So we're going to move this over 1, 2, 3. So what do you end up with? 0.002908. But again, what can you do? You can multiply 2908 times 1 and get 2908 and then move it over 1, 2, 3, 4, 5, 6 spots. And guess that's what we would do. 1, 2, 3, 4, 5, 6. So again, if the shortcuts don't work, just use what we did on the front page. Ignore the decimals completely and then worry about moving your decimal. All right, so on number 4, guys, it's just that typical, now that you know how to do the operation, can you plug it in first and then do the operation? So what operation is this when they're right back to back? Multiplication. So they just want us to take 2 times negative 0.3. Is that okay? So I plug it in first and make it look like it, but I don't do multiplication like that. Well, actually we can. What's 2 times 3? 6. What's the sign going to be? Negative. And how many decimals do I need to move my decimal point? 1. So what's our answer? Negative 0.6. You guys just did that without even setting it up, right? What's 2 times 3? 6. We knew that positive times a negative is a negative. And there's 1 decimal point, so we moved it 1 spot to the left. This one has a little bit more math going on. We have x times z, so 2 times 7.3. And then we're going to subtract a negative 0.03. Okay? So what is subtracting a negative really? Adding, right? So this is really 2 times 7.3 plus 0.3. So what are we going to have to do first? Are we going to do the multiplication first or the addition first? Multiplication. So down here, kind of off to the side, you know, wherever you want to put it, I'm going to do 73 times 2. Because remember when we do the multiplication, you just ignore the decimals completely, right? So 7.3 is like 73 times 2. What's 2 times 3? 6. What's 2 times 7? 14. How many decimal points did we have, guys? Just 1. So we're going to just move that over 1 spot. So what can I put right here? That's 14.6 plus 0.3. Is that okay so far? So I plugged in my values, x, z, and y. I realized subtracting a negative was the same as adding. Order of operations, we did the multiplication first. We got 14.6. And then what did we learn on Thursday? When you add, you just have to line up those decimal points, right? So I'm just going to come down here and do my addition. 14.6 plus 0.3. What do you guys get? 14.9, does that look right? So I'm going to go back up here to my final answer. I didn't leave a whole lot of room for scratch room, okay? So it's just kind of order of operations. C is going to be really similar, where we're going to do the multiplication first, okay? We're going to do negative 3 times y and get that answer first, and then we're going to add z at the end. So we have negative 3 times y, which is negative 0.3. And then at the end, we're going to add z, which is 7.3. Okay, so I'm just plugging in my y and my z. Okay, order of operations, yes, ma'am.
Letter B.
Mm-hmm.
Since, you said in the beginning we had to count the decimals behind it.
Right.
So since it's 7.3 and 0.3, is it going to be 2?
That's when we're multiplying. Remember, when we add and subtract, we just line up decimal points from Thursdays, right? So it's only when we're multiplying do we move the decimal points. When we add or subtract, we just line up decimal points, okay? And that's what's going to be hard, is we're going to have these different rules. All right, so we're going to do the multiplication first, guys. What's a negative times a negative? Positive. What's 3 times 3? 9. And then how many spots do we have to move the decimal? 1. Are you guys okay that that's just 0.9 there? Plus, what behind it? 7.3. I'm going to come down here and do my little lining up of decimals. 3 plus 9 is 12. Carry your 1. 1 plus 7 is 8. And bring your decimal straight down. Did you guys get 8.2? Okay. So order of operations is a negative times a negative is a positive. 3 times 3 is 9, and then there was 1 decimal point. So we moved it over 1 spot to get 0.9. 0.9 plus 7.3, we just lined up the decimals, and we got 8.2. All right, are there any questions on 4? So where can we use this in our real life? We can use it with circumference. Does anybody know what circumference is of a circle? It's the distance around it. So technically, it's the perimeter of a circle, right? But the circle doesn't really have sides, so like how do you add up sides? You can't. So the circumference is, there's 2 formulas. I should write it somewhere. There's not a whole lot of room. Let's write it over here. C equals 2 times pi times r, or C equals 2 times, no, not 2, sorry. C equals pi times d, which is diameter. And I'm going to box that and star it. I need to just type it in my notes. I apologize, okay? R is the radius. So that's from the edge to halfway in. It's to the center, okay? And then d is called the diameter. The diameter is straight across, okay? So notice the only difference between these 2 values is if you use the radius, you need a 2 there because 2 radiuses make a diameter. That's all that's showing you, okay? So really it's just pi times d, which is really cool. If we had time, which we don't because this class has so much that we have to cover, it's really neat to discover this on your own. No matter how large your circle, the ratio between your radius and your circumference is always that 2 pi. It's weird how it all works. So like we have like this thing where we measure the string, we measure the radius, and it's always 2 pi. But anyway, what they want us to do is pi is a ratio between your diameter and your circumference. So it's approximately 3.14. Some people pride themselves on knowing thousands of decimals. Like it goes on. It's like it's never ending. It's 3.14 with a bunch of decimals behind it. So people brag about, oh, I have it memorized to the 100th decimal. I don't know what that gets you, but brag about it, right? Okay. So a lot of times we just use it as an approximate number, okay? So pi is just kind of a variable. It's a symbol. A lot of times we plug 3.14 in for it, okay? And that's what it's telling us to do. So see how we have the radius? So we're going to use this formula. C equals 2 times pi times r, okay? I like to start with the generic formula so you guys can see kind of what every part of it is. Why do we need 2? Because 2 radiuses go across the circle. What did they say to use for pi? 3.14. And what did we find out our radius was? 7. Does it matter what order we do the multiplication in? No. Why am I pointing that out? Because when you look at 2 times 3.14 times 7, what 2 numbers are really easy to multiply? 2 and 7, right? So what I'm going to do is I'm going to multiply these first. What's 2 times 7? So really we're just doing 14 times 3.14. That way you only have to set up like one multiplication problem. Does that make sense, guys? Because you could do 2 times 3.14 and move your decimal over, and times it by 7 and move your decimal over. Or you can say, hey, 2 whole numbers multiply very easily, so let's just do those first, then multiply by 3.14, okay? So this is 314 times 14, so those that came in late, when we multiply with decimals, we kind of ignore the decimals, all right? So 3.14 is like 314. 14 will be 14, so we ignore the decimals completely at first, all right? So 4 times 4 is 16, put your 6, carry your 1. 4 times 1 is 4, plus 1 is 5, and then 4 times 3 is 12. Do you guys get 1256 on that? Yeah. And then we're going to shift over, so we're going to put a 0 there, and we're going to shift over to our 1. 1 times 4 is 4, 1 times 1 is 1, 1 times 3 is 3, and we're going to add at the very end, okay? So 6 plus 0 is 6, 5 plus 4 is 9, 2 plus 1 is 3, and then we have 1 plus 3 is 4. Once you do your multiplication, you say, well, I didn't really have 314 in the beginning, right? I had 3.14. So you go back and say, how many decimals were there? There were 2. So I need to move my decimal over 2 spots, okay? So your decimal's right here. Boop, boop, okay? So since it's perimeter, it's going to be 43.96 feet. It's not area, so we're not going to square it. It's just going to be 43.96 feet. All right, B, what's the only difference, guys, is now we're given the diameter. So which formula we're going to use? This one that has the diameter, okay? So we have C equals pi times D, where what are we going to plug in for pi? 3.14. And what are we going to plug in for our diameter? The diameter they gave us, the 16. So this is really 3.14 times 16. Is that okay? So again, I'm going to ignore my decimals completely and just write this as 314 times 16. And I'm going to shove it in here, okay? 6 times 4 is 24. Put your 4, carry your 2. 6 times 1 is 6, plus 2 is 8. 6 times 3 is 18. So I got 1884 on that first go. I'm going to shift over to the 1, so I'm going to put a 0. 1 times 4 is 4. 1 times 1 is 1. 1 times 3 is 3. And I'm going to add. 4 plus 0 is 4. 4 plus 8 is 12. Put your 2, carry your 1. 1 plus 8 is 9, plus 1 is 10. Put your 1, carry. Did you guys get 5024? Does that look right? Mm-hmm. And then you go back to your original. You say my original problem had 2 decimals, so I'm going to move this 2 decimals. So our final answer, guys, is 50.24 inches. Do we need to do C, or do you get what we're doing?
I have a question.
Yes, ma'am. Yes.
So I was jumping ahead.
Yes.
I started C.
Mm-hmm.
And I got to like multiplying it, so it'd be 314 times 103. Can I just ignore that second line where I multiply the zeros and just jump over 2 more spots?
You can, but be careful, because since it's radius, you should be using this formula, 2 times pi times r.
That's what I'm doing.
Yeah, but absolutely. So she's just saying, because you know it's all going to be zeros,
Yeah.
you can bump over and make sure you just have 2 zeros to get there, yeah.
Okay.
Are we okay, guys? Is that all right if we just move on? I feel like I'm boring you. All right, so the last 2, this is kind of interesting. Have you guys heard of all the news about like the Mega Millions and all the jack they're talking about it? So this kind of gives you an idea of like what it looks like. So a lot of times millions and billions and trillions have tons of zeros, so we just write the word out, right? So like 57.6 million, but they want us to write it in standard form. So standard form means the actual number. So what we're technically doing is we're doing 57.6 times 1 million. Well, 1 million has 6 zeros behind it, because this is 100s, thousands, millions. So if you remember, we can sit here and do the multiplication, or the trick was, how many zeros did we have? 6 zeros. So what we can do is we can take 57.6 and move this over 6 spots. 1, 2, 3, 4, 5, 6, and put your 0 there, or your period there, okay? So really, we're adding, what, 5 zeros to the end of all this? Oh my goodness. Look how big this gets. So we have 57,600,000 is what that looks like.